So today I would like to talk about how applications that are signed off for at some point in time can be broken shortly afterwards. So who am I? I'm principal security researcher at Fortify, which is now an HP company. I started roughly 5 years ago on our static analyzer. I have a background in code obfuscation and binary rewriting, where I used to use a static analyzer to do that kind of things. So that's how I rolled into Fortify, because their flagship product is a static analysis tool called SCA. And I started off writing rules for Java, PHP, .NET, and so on. I also created a special rule pack, which is called the Insider Threat Rule Pack, how you can actually find insider threats by means of static analysis. But more and more I rolled on to the runtime side of the house. Not a lot of people know that we have some runtime product too. We have, for instance, RTA, which is some sort of web application firewall. We have Security Scope, which works together with WebInspect. And I also worked on Hybrid 2.0, the correlation story, let's say. And eventually, these days, I'm working more on gray box analysis and integration between different products. And today, I also want to dive deeper a little bit on gray box analysis, what it is, and so forth. So what I'm going to talk about today is a short introduction, and then I'm going to go over a test application. So for some reason, we were doing a project and we needed a test application, and a test application which was thought to be secure in 2010. 2011 came along, and in 2011 what people always find is like new vulnerabilities coming along, new analysis techniques, and that same code base was actually broken in 2011. It was the same code base, but because of these new vulnerabilities, because of these new assessment techniques, they were able to find new vulnerabilities in that application. And then of course I'm going to offer you guys a solution how to protect yourself against a scenario like that, which is called continuous testing. So we were actually working on our gray box analysis, and we wanted to take an application to find some empirical results, to figure out if our analysis was really working. And the criteria were fairly simple. We wanted to use an application that was extensively used and that had undergone some security improvements. So we didn't want to take any random application. We really wanted to take an application that was heavily used and where people also thought about the security of that application. And that was the start of the project. But eventually it became more than that, because we found that application quite interesting, and we did more than only the empirical results for gray box analysis. We also hit it with a white box tool and also with a black box tool to just figure out if we could find more in that application. And turned out we could. So with that base set of criteria, we went out there and we looked for a CRP or an ERM solution that was heavily used. As our project required Java or .NET, we were of course limited to these two languages, but that's fair, right? And of course it had to be open source. We had to be able to look into the code and see if the vulnerability is really there, and be able to fix the vulnerability afterwards, of course. And we quickly stumbled on Apache Offbuzz. Apache Offbuzz is a CRP and ERM solution, which we found quite interesting because it showed up in lists like as the #1 open source ERP software solution and so on. But from our perspective, we really liked it because a lot of end users are using Apache Offbuzz. For instance, it is used in 1-800-Flowers, it is used in Olympus.de, United.com, BT.com. So a lot of the end users are really relying on that piece of software. So that's one side. But on top of that, a lot of other projects and products are based off that code base. So not only do they have a lot of end users, they also have a lot of projects which are built on top of that. And one of the most famous one is OpenTaps, and that framework or application is again used by other companies, like I think Honeywell is using OpenTaps internally, and so on. From a widely used perspective, this was really the application we wanted to target. It is really widely used. And then we also wanted to look at the security side because, if you take an open source application and you run a scanner on that, you can find a lot of vulnerabilities. So we really wanted to take an application where people thought about security. And if you look into this CVE, for instance, vulnerabilities date back to 2006, around the time they open sourced Apache Office. And these people really fixed the issues. Okay, so they really did something about security. And one of the most notable things was a video that I came across was about a security research company who found a couple of cross-site scripting issues, and to prove their point that cross-site scripting can be really dangerous, they posted a video how you could exploit these cross-site scripting issues and become an admin. So they posted the video with, so don't try to read this, the screen is super small. But so these are just screenshots from the video. So in the video, they really tell you, for instance, put script and so on into this specific tag, this is a mailing form, put some script in there. They give you also the scripts that it is relying on, so you have to, you have practically everything you need to become a root on an application that is relying on a previous version of Apache Office. So first you go to the mailing form, you put in a specific script, you mail something to the administrator opens that, he gets the cross-site scripting, and in the background what is actually happening is the user, the administrator is actually adding the user to add admin credentials and adding it up to the list. And to prove their point, they log in as that particular user and they see the fact that they have full admin privileges. So that's quite a big of a hiccup, right? But okay, none to say, so the Apache Office team reacted on that. They opened bugs to figure out, well, this is one scenario, right? This company stumbled on, I think it was 5 cross-site scriptings. They fixed these 5 cross-site scriptings, but I dig into their bug database, and around that time, so they thought like, wow, these people were able to do that, and they gathered information from different resources. So they did not only look at the video, but they also went out on the internet and figured out, hey, are other people also doing stuff like that? Who has more information about our application? So they gathered some knowledge and they actually fixed it. So around 2010, April, the 4th month is April. So around 2010 in April, they released a new version of Apache Office, the 10.04, where they actually fixed everything that they knew about. So, and essentially you can state that in 2010, at this point in time, they thought their application was secure. They tried what they could do to make their application secure. Okay, 2011 came around. What changed in 2011? Well, not much, but on a constant basis, white hats and black hats are finding new ways of attacking applications and taking applications down. One of these new ways was, for instance, the denial of service parse double one. So, and I'll take that one as an example through the first part of the slides. So, new vulnerabilities appear in 2011. Any year, new vulnerabilities appear found by black hats and white hats, and this makes actually your current application, which is in production, vulnerable to these new vulnerabilities. Because in 2010, you didn't know there was a possibility to exploit something like a parse double and take your application down. So you were not aware of that. You couldn't even protect against that. Okay, that's one thing, new vulnerabilities. Second thing is, people are very creative in coming up with new ways of analyzing applications. So we are well aware of black box and white box, but you can, for instance, come up with hybrid techniques and with techniques like gray box analysis. So what gray box analysis is doing, it's finding more of the same. It's finding more of the cross-site scripting, SQL injection issues that you have in your application, but they are using a new technique to be, for instance, more accurate, finding new vulnerabilities in portions of your code that you didn't test before, and so on and so on. So I'll I'll dive deeper into gray box analysis as an example of how new analysis techniques can find more of the same. So in short, in 2011, you can have new vulnerabilities and new ways of assessing applications. So let's start with the first one. It's the denial of service parse double one. So what's the problem? The problem is, I've taken this information from the CVE itself. In the Java runtime environment, if you try to convert a string, this specific string, 2.2 and so on, to a floating point number, well, internally the Java runtime environment is trying to switch back and forth between two numbers, trying to figure out which one to pick, and eventually it ends up in an endless loop because it's not able to figure out which one of the two it has to take. Okay. This vulnerability came around in February, and actually on the right-hand side at the bottom, what you can actually see is that it was fixed in record time. This vulnerability was really fixed in record time. February 8th, there was already a patch by Oracle to fix this particular problem in the Java runtime environment. More concrete, what are we talking about? So in Java, if you have the double parse double API, and that takes one argument, if that one argument is that very specific value, then you go into an infinite loop. It's as simple as that. Now you can ask yourself, well, this came around in 2011. Well, not really. This problem was known for a long time. It actually dates back to 2001. So this vulnerability was first discovered in 2001. And it was given a 4, I think, a very low priority. Why? Because you can think like, what are the chances that this value, this 2.2 and so on, actually appears in your application? Well, practically none, right? This value will not appear in your application. So why did the people fix it in record time after they rediscovered it in 2011? The fact is, in Apache Tomcat, it is really heavily used. Well, not heavily used, it's used in a critical way, which is if you have one of the headers, the accept language, if you have one of these headers, you can put that special value into one of these headers and you will hang the application server. So no matter what kind of application you're running on top of Apache Tomcat, you just need that header, you have to inject that special value and you hang the application server. So no matter how secure your application is, it's an application server problem and you hang the application server. Okay, so this is a problem. And we were wondering, well, is Apache Offbus vulnerable to that? And we did it in two kind of ways. We used static analysis, white box analysis, and second we used the penetration testing, black box analysis. Static analysis, just briefly saying what static analysis is, it's really looking at the code. It's looking at the code without executing the code. So you just take a sheet of paper and you print out the code and you just look at the code and you try to figure out if there's a problem with that piece of code. Penetration or black box analysis, it's really running the application and attacking the application and not knowing what's in that application. So you treat it as a black box. You do not look inside that application. You just treat it as a black box. You send out attacks, and based on the response, you try to figure out what happened in that particular black box. Okay. So first of all, the most easy way to think about a white box approach is just a simple grab. So you can just grab on the code, for instance, and you can grab on the code and figure out if that API is used. That's the very simplest way to think about white box analysis, because you're not executing the code, you're just interested in what's in that particular piece of software. So if you do a simple grab for that API, you can find around 25 times that API is used. Well, that's useful to know, but that doesn't tell you anything about the secure if that API is überhaupt possibly triggered by a malicious person. There still has to be a path from the source up till that API to exploit that vulnerability, right? So a smarter way to do that is try to use something like a static analysis tool, where you try to figure out paths through your application from where an attacker can inject something up till that API. And if you do some analysis like that, well, you can find quite a number of these problems, these denial of service parse double problems. I've just put up one example over here. On the left-hand side, you see, for instance, that from the input.java line 54, so over there, the static analysis tool thinks that input can go into the application up till the shopping cart item, which is a sink. So from that input to that sink, the shopping cart item, the static analysis tool thinks that there is really a path from that entry point to that sink. On the right-hand side, you see really what kind of path the static analysis tool thinks it's going through. So it goes from get text, and it's going through the menu events. Eventually, it goes to the shopping cart item, and in the shopping cart item, over here, it's about the quantity of an item. So if you want to order 3 or 4 items of that particular item that you want to purchase, well, if you put in that special value, a static analysis tool thinks that you can take down the application. This is pure theory, because you look at the code, right? It turns out that this is actually possible in practice too. So this is a real vulnerability where you can take down the application by simply putting that special value in the quantity field. So that's one thing. From a black box perspective, just sending out attacks, it's fairly simple. Everybody can do that. Apache Offbiz is open source, so you take Apache Offbiz, you run it, and then you take a penetration testing tool, an open source one or whatever. You put in that special test to say, hey, I want to look for denial of service parse double. Just try every field with that special value, and let's figure out what's happening. Turns out it's full of this. Of this particular problem. So this is just a simple list of how to take down with a black box analysis tool the Offbiz application. Of course, one downside if you do a denial of service attack is the fact that you have to constantly restart your application server because you're taking it down, of course. Now, you may ask yourself, like, what are you talking about? This is not about Apache Offbiz, right? The root cause of the problem is really it's a Java problem, right? And that's totally fair. The root cause of this problem, this is not a problem in Apache Offbiz. The root cause of this problem really relies in the GRE, where that specific piece of code is parsed to a floating point. The problem is, in production, you do not have that flexibility to update your GRE on the fly, right? Sometimes it has to be signed off by this and that guy, and for some reason it's not even possible to go to Java 6 update 24 or later. So people are aware of that problem, and even the Apache Tomcat people are aware of that problem, and they say, hey, it's not possible for everybody to go that latest Java version. You know what? We can still do something in our code too. You know, it's not our It's not our problem, but we can still do something to prevent that from happening. So the Apache Tomcat people fixed it in their code too and pushed out a new version of Apache Tomcat. So if you're taking one of these Apache Tomcat versions, no matter what kind of Java version you're running, you're at least protected against that header problem, you know, that I talked about before. So at least you're protected against that problem. So, okay, so I just wanted to say that in Apache Tomcat, the way they fixed it is really by using a whitelisting approach. So what they did is, hey, they said the number of the length of the string that we want can be longer than 5 characters. So they really limited the number of characters that they were going to parse into a floating point, which is really whitelisting approach. So that's really a good way of fixing the problem. Just for completeness into the slides, I also show the Java fix. You can go through that in the slides, which are on the DVD or on the CD. What is it? Other people say, well, you don't have to, even if you can't do anything. So if you cannot update your application, or if you cannot update your Java, you can still rely on a web application firewall, which is true and true for some cases, but you cannot protect, for instance, against persistent threats. So if somebody already was able to put that special number as his username, well, try to get that from the server, because it will never go back and forth between the clients. So the web application firewall can't do much. I've seen this actually for real. And the CVE tells you one number, 2.2 and so on, exponential minus 308. And you can install a rule that figures out that exact number, you know. But of course, if you shift the comma or the dot a little bit, you can go with 0.2 and so on, exponential minus 307. Well, did you think about that in your web application firewall? I hope so. Otherwise, it's not protected at all. So you have to think about a lot of things. Additionally, but I do not believe this one, but I found on the internet that some people claimed that there is like that one special value, but there are other very small values that tickle the same vulnerability. Well, what are these values, and did you protect in your web application firewall against these values? So if you do it in a web application firewall, sure you can do it, but you really have to consider every possible scenario and protect against every possible value that can tickle that particular vulnerability. Okay, so that's the first part. New vulnerabilities can take down your application. Second part, gray box analysis. What's gray box analysis? Let's first start by introducing a little bit what black box testing is. So black box testing is about system level tests, so no network level tests. We do not make any assumptions about the implementation. So a black box testing tool or a penetration testing tool will behave exactly the same on a banking application as it will on a telco application, as it will on any other application. Even within that application, it will behave pretty much exactly the same on the logins page as it will on the payment page, as it will on the questions page, let's say. So no assumptions about the implementation. A good example is fuzzing, where you send random data, well-structured random data to the application. Maybe a better example with application security is penetration testing, where you do a little bit smarter things, where you look for known vulnerabilities or things that you know that can break in the application. So it's more well thought of attack vectors. The good thing about black box testing is you have really concrete results. If you have good results and you go back to your developers and you say, hey, this is a problem in your application, and your developers say, no, that's perfectly fine. Well, you can actually show him, and you can actually wipe his database, or you can do whatever, and then he will pretty much believe you that there is a problem in his application. On the other side, it's kind of a losing game, because normally when you do not have a lot of time to do a pen test in a lot of cases, so and you're not able to penetrate the entire application, like the whole attack surface of the application can be quite problematic. Did you really cover everything in the application? Well, that's really hard to say, right? So that's a little bit the bad side of penetration of black box analysis. What's white box testing? As I said, white box testing is really examining the implementation without executing the implementation. But everything is fair game. So you can put the documentation, you can take the documentation and try to figure out what they're doing. Everything is fair. You really have everything in your power to request everything to anybody in the company, and they have to tell you what the application is doing, and then you can assess it. You can also test components in isolation, where in penetration testing or in black box testing, you have to get the application up and running, and then you can do your tests. With white box testing, you can really take a component, pull it out, look at that piece of code, assess it, and then that's it. A good example is, for instance, static analysis. The good part about white box testing is that it is thorough. You can consider every path in the application. Even if it's theoretically possible, we always try to make sure that it is practically possible too, but it's super thorough. And that may be also the downside, because if you have a static analysis solution at first, well, it may come up with a lot of false positives because it needs some tuning to get rid of, to map your environment better. And there's also no show me exploit. If you go to your developers and you say, hey, this is a problem, and they want to see proof, well, good luck, because then you really have to come up with an attack that exploits that vulnerability or that potential vulnerability that you talked about. So there's no show me factor. What's gray box testing? Well, gray box testing is really marrying the two testing environments. It's really about black box testing and white box testing. You take the two together, and it's like in a real marriage, you just try to overcome the other person's problems or flaws. So you really try to make the best of it, and you try to take the strongest components together, and that's what gray box analysis is. So now I see you guys thinking, well, this is another hybrid talk, you know. No, so there's a clear difference between hybrid analysis and gray box analysis, and I'll show you in the next slide. So what's hybrid analysis? Hybrid analysis is really trying to correlate issues together. So there was a lot of buzz about hybrid, and people think that this will be again about hybrid. It's really about, hybrid is about, you take a dynamic analysis and you take a static analysis results, you blend them together, and you hope that magically these issues will correlate with each other so that you can have an outside view and an inside view of that issue. Smarter solutions come up with something called a monitor, which sits in the application server, but again, it's run separately. So you have the dynamic analysis results, you have the monitor results, and you have the static analysis results. So in short, what you're talking about is you have these three different result sets, and you can couple them together. So you can actually do really nice correlation with these three sets. So for instance, you have the black box results, which is mainly a URL, and you can uniquely identify every attack that you send out. If you have something called a monitor in your application server, which observes everything that comes in and can also look into the code to figure out what's actually executed, well, that monitor can create results that say, hey, well, this URL came in with that specific ID, and it executed a portion of the code, this piece of code. Well, we can record that because something is off there, like some SQL injection or something is happening over there. Static results, again, you do a static analysis and it finds some vulnerabilities. This is really about files and line numbers and issues on the code itself. And of course, now there's a nice flow where you can correlate that black box results together with that monitor result, together with that static result. And eventually what you can do is you can say, hey, this URL was vulnerable. Well, you can couple that back to a static result, and I can actually show you in the code where that problem occurs. That's hybrid. You have three different components. They have nothing to do with each other, and in the end, you blend the results together, and you have some correlation between the results. Gray box analysis is really about, again, you have the dynamic analysis, so let's say the pen test, that sends out attacks to the application, and it receives some information back from that application. But in that application, or in the application server, you can install a monitor which observes everything. But the really cool trick over here is that there is a real-time connection between that pen tester and that real-time monitor. So they can actually share information. So if the attacker sends out an attack, the monitor or the real-time analysis can give some real-time feedback like, hey, you did something over there. Well, that didn't quite work out. You know what? Try something over there because we think that that's a better possibility. So there's some real-time link between these two components, and they can share information. They can give hints to each other. Everything is possible over here. What's the real advantage of gray box analysis? It's find more and fix faster, which I'll gonna explain with a couple of examples. So first of all, find more. as I said in the beginning, you will find more of the same, first of all, but you can also find new vulnerabilities. Like a pen testing tool cannot look in the application itself. It can only rely on what's coming back from that application server. So it can find stuff like cross-site scripting. That's obvious because it's in the page, it's on the client side, it comes back. It can find SQL injection, it can find command injection, only if something comes back from that application server, which indicates that there's something wrong in the application server, that something is happening in the application server. But stuff like privacy violation and log forging, well, there's no way a black box solution can find that, because that's some problem that purely happens in the running application itself. Nothing comes back that says, hey, you know what, some privacy violation occurred in the application server. No, so there's no way of knowing that. And then you can also find more of all kinds of vulnerabilities. Automatic attack surface identification and understand the effects of attacks. And I have a couple examples of that. So attack surface identification. Let's say you start in crawl mode and you go to the login page, and from that login page there are some links to the account page and to the balance page. So your black box analysis can first of all find these pages. Second, it can assess these pages and figure out if some problems occur on these pages. But let's say there's also a backdoor page on that server. Well, if there's no link from the application itself to that backdoor page, well, the crawler is not possible to find that backdoor page. Well, now you see that one coming. With the real-time link, well, what the real-time link is, the monitor can actually cheat and can say, hey, there's no link to that page, but you know what, there is a backdoor.jsp, so please consider that one too. And of course, it will consider that one too. The way it works internally, so that monitor can look at the file system, so it can just figure out what kind of directories are on the file system. Did we tickle every directory? It can look into the configuration and try to build up all the pages that are possibly accessible on the application server, or it can also go programmatic, where you can just go over the code itself and figure out where there are, for instance, get parameters and what kind of input they are requesting. In Apache OffBiz, well, you point at one page, and then from there the tool takes over and it tries to crawl all the directories. So this is just from a high level, this is the number of directories that it finds without additional information. So if you do a pure black box analysis and you point it to the main page, this is the number of directories that a black box tool can find. If you have some component that cheats, actually, well, you can find 3.5 times more directories. 3.5 times more directories and files that are accessible for the pen tester now, that are accessible, and that the pen tester can try to figure out if they are appropriately protected against all vulnerabilities. And in essence, there's no longer a need for a crawl, because with that component, you can simply cheat and tell the pen tester where to find what kind of files. And as I have to say, this attack surface identification is also the direct thing where we find more vulnerabilities. Because we have that bigger attack surface, the pen tester can assess more pages and we can find more vulnerabilities. The second one is understanding the effect of an attack. Let's say you found that backdoor.jsp and you're sending out attacks, but really nothing is coming back. What does that mean? Does that mean there's no vulnerability? Does that mean something happens in the background? And what does that mean? Well, let's say you did something and you actually opened or injected something and it was a successful command injection. Well, with that real-time link, before you couldn't report because you didn't know what happened. With that real-time link, you can give that information back to the black box testing tool, and you can say, hey, you know what? You did tickle a command injection. You were successful. You were able to create a bash on the server, and it was actually successful. So then you can report that back to the user. Okay, so the first one was to find more. The second one is to fix faster. Before, if you have a pure black box solution and you send out attacks, and you go to your developers and they have to fix that, well, sometimes they do not know how to fix that. They say, yeah, we see that it is a problem, but where exactly is the problem in our code? You didn't give me enough information to fix that particular problem. So over here, we can give you more information. Second one is group symptoms with common cause, and I have an example of that one too. So first one is actionable details. So before, you could only provide the person with the URL. Now with that real-time link, what you can also do is when the vulnerability happens, you can actually take stack traces. You can figure out what kind of data was sent over, how that data was modified within the application. All this information can be collected, given back to the pen tester, and that can be in the report. So this is really, really useful for a developer who has to fix that particular problem. Because before he was given a URL and he had to fix it, not knowing what to fix first of all and how to fix it. Now he gets a lot more information about the internal side of the application, really knowing line of code detail about where the problem occurred, and he can actually be given more information how to fix that problem. So we found a ton more cross-site scriptings in Apache Offbiz, and everywhere that there is a green dot, we were able to give more information about that specific cross-site scripting problem. So as I said, the direct lead for these new cross-site scripting issues was really the bigger attack surface that we had. We found more directories that were open, and because of that, we could assess more pages and find these new vulnerabilities. So in the CMS side, for instance, there was a vulnerability, and it gives me the indication that there is more information to look at. So if I look into the more information over here, what I can see is, for instance, what triggered this particular vulnerability in the application. So in the application, at some point in time, there was a write, actually a print writer over here, so a print writer append of this piece of data. So in this piece of data, there is like no subcontent found with map key, and then over here there's a clear cross-site scripting vector, and then for content CMS point. In the stack trace, when that happened, we collect the stack trace, we give that information back. There's also like the last line in the application code. So the last line in the application code says, hey, you know what? In contentworker.java, line 358, we went to the print writer, and that eventually got written out. So if you look into the code, what you find over here is exactly the line that the developer is interested in, because now it tells you like, hey, in that line of code, you have the out.append, no subcontent found with map key, and then the map key. So apparently the map key is vulnerable to cross-site scripting for content and the content ID. So this gives the developer a real handle on how to fix that problem. So he has to be aware of that map key and properly cleanse that map key. Okay. Second one is group symptoms with the common cause. So these days, so when I started actually doing that gray box and the empirical results for gray box analysis, I had a problem. I had a problem in the sense that I wasn't able to count vulnerabilities. How hard is that? I wasn't able to count vulnerabilities because, so I found the vulnerability on the login page. So you have one symptom of cross-site scripting. Then I found the vulnerability in the account page. I had a second vulnerability, a second symptom of cross-site scripting. I found the cross-site scripting in the balance page. I had a third one. But turns out that all these cross-site scripting issues led really to one specific problem in the application. So now I was wondering, well, how many cross-site scripting issues did I find? Did I find 3 or did I find 1? And I wasn't able to figure that one out. Eventually, you want to know both numbers, because from an attacker perspective and from a business perspective, well, there are 3 ways to exploit the cross-site scripting. On the other hand, from a developer perspective, if you fix one issue in your code, you can actually wipe out 3 possible attacks on your application. So you really want to know both. And that's interesting information, because now you can group together issues with a common cause. So for instance, these 5 issues on the web slinger directory can be grouped together. Okay, so there are like 5 possible ways to perform a cross-site scripting on different directories, and in the background we were able, with that runtime, with that real-time component, to figure out that, hey, all these 5 issues really lead to one cause in the application. Okay, so what was that common cause? Well, eventually what happened was these 5 pages went to a 404, a special 404.vtl, and there was a page built out of that 404.vtl with different names, of course, in the end, but they all contained this cross-site scripting issue. So these 5 problems all lead to one cause. Okay, and that's really how a little bit of the proof and where to find it in the code. So in the code, it's a simple cross-site scripting. In the 404, it tells you, hey, the file was missing. And if you put, of course, a cross-site scripting vector in that file name, well, then of course you can exploit this if there's no proper cleansing. Okay, yeah. What we want to do more with that gray box kind of analysis is anti automation. Okay, I still have time. Which is the fact that before you really monitor the application, right? You do not interfere with that application, and people really want to do a pen test without changing the application. They really want to test that application in production like it would be in production. But some people are using then these kind of CAPTCHAs, and they want to keep that in, but then automatic pen testing solutions have problems with that. So a way to look at this is, if you have some runtime component, what you can actually do is you can bypass that anti-automation system. Okay, so you're really going to test the application, which will be put in production without hard code, without changing the code, but your runtime component will make sure that you can actually test that kind of application. So these are kind of the next steps that we're going to do. Okay, the solution to the problems that I talked about. So first of all, the solution to fix the code that I showed, and second, the solution, how can we actually protect ourselves against application that we put in production at some point in time against vulnerabilities and assessment techniques of the future. The solution, so I actually found that in the bug database. So for open source, you can do it yourself. The policy, and I really found that. I think the policy is a bit more like this: if you want it, either do it or pay someone else to do it. So the problems that I enumerated over here in these slides. If you want to protect yourself against the denial of service, make sure you run Java 6 update 24 or later. And this is really about if you do not have time, but you have that application running in production and you read a fix right now, this is what you can do, or should already have done this. Second, in the WebSlinger component, just remove that one variable, and then in this Java file, just remove the map key. It's only used to spit out more information about errors in your application. So just don't output that piece of information. And the solution to keep it protected, and I was actually a little bit stunned when I found this particular bug report in Apache Offbus. So they had, at some point, we had some open source security reporting mechanism. So everybody who had an open source project could submit it. We did an assessment and they could access it for free and just fix their code. At one point, they looked at one of these assessments and they looked through the report and said, hey, nothing is wrong with that application, so they closed it. Well, the problem is really we are constantly updating. As I said, when new vulnerabilities come out, we really update these rules, and we really make sure that they are up to date. And these rescans are not simple rescans. They will not give you the same output, but these rescans will really take the latest security knowledge and give you the latest results. So closing something like that is really, well, problematic. You constantly have to look if something new is broken in your application. You constantly have to be aware of the latest in security, right? And a second thing that I thought about was, well, you have this whole security through the development lifecycle, right? At certain stages in your life cycle, you can do different things to protect yourself. So you can do static analysis when you write the code. You can do gray box analysis or penetration when you test the code. And when you and in operation, you can use a web application firewall. And the problem is really once your application is in production, you rely on a web application firewall and a pen testing solution to protect yourself against new vulnerabilities, which is kind of odd, right? Because as I said, new vulnerabilities come out and you're not retesting this application anymore. You do all these steps throughout the development lifecycle, but once it is in production, well, then it's done. You know, it's secure, it's signed off for, we put it in production, we're done. We're not going to retest it anymore. Well, that's kind of odd to me because, again, new vulnerabilities come out. You should constantly retest, even if it's in production, because you can still find new things on that running application. So even if there are no code changes, keep on scanning, update with the latest security information. This is no rocket science. And the second thing that I touched on in this application, the solution to keep yourself protected is if there are like new assessment techniques, well, try them at least out. Try them out and figure out if they work on your application. They just find more of the same stuff, but vulnerabilities that you may or may not be aware of. Also, work the scans to tune them to your environment, because not everything works out of the box when you try to find stuff like that. So we really tune and work that environment to make sure you have the latest and greatest on your application in production. So this was really my talk. Thank you very much for your attention, and I still have some time for questions. So if you have questions, you can ask them now. Everybody wants to go out for a beer, I think. Good. Thank you very much.